From now, we are going to start the advanced section of EIGRP, the operating system, EIGRP. We learned how to enable EIGRP, the bandwidth command, the delay command, which are all optional. We learned them. We learned how to enable EIGRP by putting router EIGRP autonomous system number. Then we used network command to advertise networks. We learned how to use wildcard mask. And we also learned how to use the IP default network command and define the default network and use the EIGRP to propagate the default route. In advance EIGRP option, first thing that we are learning is the summarization. You see, any protocol, summarization is very important. Summarization improves the efficiency of the network. If you do summarization, the routing table is going to be small because it's been summarized. The update that's sent is going to be small. When a small subnet goes down, there is no need to send an update. For example, here in this diagram, we have 172.16.x, meaning in the third octet, you got numbers starting from, let's say, 1 to 254. 172.16.1, 172.16.2, 3, 4, 5. You got 254 subnets of 172.16. Instead of advertising this 254 subnets, when you summarize, you just advertise only one instead of 254. So definitely the bandwidth utilized is going to be less because the update is 254 times lower. Secondly, the receiving router is processing just one line, 172.16.0.0, instead of 254 lines. And if any subnet fails, for example, 172.16.100.0 network failed, went down, there is no need to shoot an update. Why? Because this summarized route not only includes 172.16.100, it also includes 1, 2, 3, 4 till 254. Only when all this 254 goes down, an update will be sent saying 172.16 is gone. So for a small changes, for a small subnet failure, there is no need for flooding of update. There is no need for trigger update. That reduces the CPU utilization, bandwidth utilization. So summarization is really good. So when you do summarization, it need not to be to the major network boundaries, though it is written, in the second point, first subsection, on major network boundaries. No need. This example shows it has been summarized to major network boundaries. That is what called as auto summarization. Auto summarization is summarizing to major network boundaries. 172.16 means what network? What is the major network? /B. 172 is slash B. So summarizing to slash 16 class B is what major. 100 or how do you summarize? Slash 8. That's the major network boundaries. Class full boundaries. So this type of summarization was enabled by default in EIGRP earlier version, but current version they don't do summarization. Current version they don't do summarization. Here it is written automatic summarization occurs by default. This is only in the older version. Today if you want you can enable them, but we don't need to do summarization for a small network. So in today's EIGRP, the newer EIGRP which we are running in our lab, summarization is off. It will not do automatic summarization. But just one command is there, auto summary, that will enable automatic summarization. Automatic summarization is nothing but sealing it, rounding it to the major network prefix length. Prefix length means subnet mask length. The number of bits given for network is what we call as prefix length. All right. So automatic summarization is summarizing to the major network. And if you want, you can enable today. It's not occurs by default. So this line is not valid. Today there is no summarization by default. Now there is another summarization called manual summarization. Manual summarization is not summarized to class full. You can have any prefix length. That's what it means.
Sir, excuse me, sir.
Yes, please.
So can you just explain this slide once again? I don't know if it was my Wi-Fi or your one. Your voice was always breaking up. Can you just quickly explain this once again? I was not able to hear you.
I'm doing it now. Sorry for that. There is no power in my side. Maybe some network issue. Let us do. Say I have 10.1.1.0, 10.1.2.0, 10.1.3.0, 10.1.4.0, 10.1.5.0. Just 7 subnets. Now, when we run EIGRP on this router, R1 and R2, Router 1 will summarize by default in the older version to this. Router 2 learns a summarized, and it is /8 only. That is what called as class full boundaries. Yeah, because it is 10, 10 means class A. Class A means only the first octet is network.
Yes, sir.
That's why it is /8. This is auto summarization. And this auto summarization is turned on by default in the older version. But in the newer version, only when you need it, you can turn on it. Fine. Now, what is manual summarization? What is manual summarization? Manual summarization is summarizing according to your need. The prefix length can be anything between 8 to 24. Can be any number. Say, for example, I just have how many? 7 networks. So I can say summarize like 10.1.0.0/16. Instead of /8 summarization, which is rounding to the major network, instead of /8, I can say /16. Then also, all this will be summarized. 10.1, 10.1, all the 10.1. I can also do more granular summarization. How? I can say 255, 255. And here, if you see 0 to 7, 1 to 7, which means 255 minus 7, 248. This is also summarization. This is also going to summarize 10.1.0.0 slash here 8, here 8, 16, here 5. So 21. See, these are all manual summarization. If you do like this, it's more accurate. If you do like this is also going to summarize all this. /16. All these are manual summarization. Auto summarization is to the major network boundaries. Auto summarization is going to be like 10.00/8. If you enable auto summarization, in the newer version I told you, auto summarization is not enabled by default. But if you'll enable, it will summarize like this and send. Manual summarization is according to your need, the length of the prefix and length of the subnet mask can be used. And now where do you do this? See, the auto summarization we do in the global router mode. For example, we go under router EIGRP and we say auto summary, which is going to be this summarization, rounding to the major network. class full network. But if you wish to do this type of summarization, this needs to be done under interface. You need to go to this interface. Let's say if it is E0, then we go under interface Ethernet 0 and we say IP summary address for what? For EIGRP, let's say autonomous system number 100, and then type this. When you do that, it will summarize to this one and send. If you check in the routing table of the next router, you will see this. Let us do this and see. First, we'll finish this. Okay, let's finish doing this. But let us read this first, and I'll go and do it. This I'll do and show you, and then I'll do this and show you. Summarization is configurable on per interface basis. Which summarization? Manual summarization. When summarization is configured on an interface, the router immediately creates a route pointing towards null 0. Yes. See, if you don't have a route in a routing table, if you don't have a route in a routing table, it cannot be advertised. If you wish to advertise this, what is this? If you wish to advertise this prefix length, it needs to be there in the routing table. Only then you can advertise it. So what will EIGRP do? When you write a summarization statement, the summarized route for advertisement will be generated first in the routing table, and then it will be advertised to the other router. Summary route will be generated, and you will see the route before advertising. You will see the route in the routing table. Unless there is a route in the routing table, it cannot be advertised. First, the route that you want to summarize should appear in the routing table. Only then you can summarize, and only then the router can advertise it. I repeat one statement, important statement. If route is not present in the routing table, that cannot be advertised. Now, if you want a summary route, the summary route should be there in the routing table. Only then it can be summarized. So when you write summary route, first it gets created on the router, and then only it gets advertised. It gets created, it appears in the routing table, only then it gets advertised. Now, let's say this is F00 interface, this is F01 interface, this is F02 interface, and so on. Which interface the summary route will be a member? It will be a member of null 0. So the summarized route before advertising, it should be there in the routing table. But the summary route is not of a particular of a single interface. It's a summary of networks which are in various interfaces. Then which interface the summary route need to point out? It will be point out to a dummy interface called null interface. When it points out to a particular interface, then loop will occur. See, this is a summary of all this interface. So the summary cannot point towards F01. If any traffic wants to really go to this interface, it will first go to F01 and it will send it to F00, it will send it to because this is a common summary for all these interfaces. So packet will be sent to various interfaces and it will cause loop. That is why it is pointing towards a null interface to prevent loop. Now, when will the summary route stop getting advertised? When the last specific route of the summary goes away, only then the summary is deleted. I told you the summary route will be first of all created locally in the routing table. When will it disappear? Or when will it be stopped getting advertised? Only when all these goes off. And the summary advertisement will also go off. The routing table pointing towards null 0 will also disappear. Now, what will be the metric of the summary? See, the summary is the route of all these subnets. Of all the subnets. What will be the metric of summary route? If the metric here is 5, the metric is 10, if the metric is 15, the metric is 7, if the metric is 12. What will be the metric of this one, which is a common summarized root of all? The minimum. So here the minimum is 7. 7 will be given as the metric for this. The minimum. Sorry, 5. 5 is the minimum. 5. The minimum metric of a specific route is used as the metric of summary route. Right, auto summarization is like this. If you want to cancel auto summarization, you put no auto summary. If you want to enable summarization, you put auto summary. If you want to disable, then you put no auto summary. This is summarizing to the class full boundaries. Manual summarization is going under interface, and you say IP summary address, EIGRP, let's say 10, autonomous system number 10, and then we say summarize like 10.1.0.0, 255.255.0.0. This is defining the prefix length as per your desire. This we call it as manual summarization because we manually say what should be the length of the subnet mask. This is the syntax for manual summarization. Go under the interface and you define the summary statement. This is under the router mode. Let us do and see this too first, and then we'll go to the next topic. So in this topology, if you see, router 1 has got 10 subnets of 10. 10.1.0, 10.1.1, 10.1.2, up to 10.1.9. Totally 10 subnets that begins with 10. And the mask is /24. On the interface, we are going to have /24 mask. And I'm going to configure this 10 network, 10 subnetted network on 10 different loopback interface. For testing, I'm going to use the loopback interface. Right, our aim is to send a default summary, auto summary to router 2. How, like this, 10.0.0.0/8. When the update is sent, it should be sent to router 2 like this. When update is sent to router 3, we don't want /8, we want more specific. Maybe we want to summarize only from 0 to 7, let's say 0 to 6. Then what I'll do is I'll say 10.1.0.0 slash 0 to 6 is totally 7 network, right? So 255 minus 7, which is 248. 248, how do you write? 5 bits. So 16 plus 5 is 21 bit. This is manual summarization. So when you check in this routing table of R3, you will find this type of summarization. From 0 to 6 it will be summarized. 7, 8, 9, 10 will be detailed. There is no summarization for this 3. So in router 3 is routing table. This is what you want to see. This is what you want to see. Whereas in routing table of router 2, you will find this, right? So this is what I'm going to summarize and send to router 3, and this is what I'm going to send as an update to router 2. So we call this as auto summarization. Even with the manual summarization, I can achieve this. But I can use auto summarization, which will automatically round to /8. Manual summarization, I need to mention the mask. And again, manual summarization is done under the interface. Auto summarization is done on the router mode itself. So when I enable auto summarization on R1, listen carefully, when I enable auto summarization on R1, both router 2 and router 3 will be receiving this summary route. After that, I'll go to the interface of R1 and I'll say, no, you need to send this. Let me show you. I'm on R1, interface loopback 0, IP address is 10.1.0.1, interface loopback 1, IP address is 1, interface loopback 2, 3, 4, 5, 6, 7, 8, sorry, slide 8, 9. All right, and then we got two physical interface F00. IP address is going to be 172.16.12.1. Interface F0/1. IP address 172.16.13.1. Let us verify the interfaces and the best places to check the routing table. You see, we have these loopbacks starting from 0 to 9. Do not focus on L, means the address on the link. Don't focus on that. You need to focus on the network. 9.0/3, 8.0/24, Don't focus on 32. And then over the interface, you got 12 network and then 13 network. IP address is 12.1 and 13. This is over the link. This is the network. Looks good. See, if any one of the interface is down like this, if it is shut down, in the routing table you will not see. So in the routing table itself, see, F01 is missing here, the routing table. So when I check the routing table, I'll know whether the interface is up or down. See, usually most of the people go to show IP interface brief, and then they see that whether it is up or down. But to know the mask that they have given, there is no information about the mask here. Do you see /24 here? No. Do you see any mask mentioned here? No. In Cisco, this is one, I can say one drawback. In Huawei router, in Juniper router, you will see the mask here. But in Cisco, if you want to know with the mask, then you need to go to the routing table. Here you see with the mask. This is the mask, actual mask given. Or you have to type the running configuration. Show run interface F00. Then you see the mask given. Anyway, that's not our area of interest today. We are focusing now on EIGRP summarization. So we got the interfaces with the IP address ready. Let's move to router 2, finish the basic IP address, then we will enable EIGRP. Interface F0/0, here only one interface, and IP address is 172.16.12.2. And on router 3, interface F0/0, IP address 172.16.13.3. Okay, we have configured. Now I'm going to enable EIGRP without any summarization. Router EIGRP. Let us decide on a number. This number that I'm typing is the autonomous system number, and that number needs to be same on all three routers. And I'm going to say number 60. And then I'm not going to use any wildcard mask. I'm going to say network 10. Anything that starts with 10, advertise. Network 172.16. That's it. So what will happen is, because all these interfaces are starting with 10, all these interfaces now run EIGRP. And then these two interfaces begins with 172.16. So both the interface will run EIGRP. How do you test it? How do you know it? The command is show IP EIGRP interface. Show IP EIGRP interface. This will show under EIGRP autonomous system 60 these interfaces. This is 10 interface and this is 2 interface. But number of line of commands that I configure is just 2. All that starts with 10. Because I said that all these are running. And then what I said, all that starts with 172.16. That's why these two are running. because on this two we have 172.16. Do you have any question on this?
No, sir.
Right, let's go to router 2. Right. On router 2, I say router EIGRP60 network 172.16.0.0, and you will see neighbor coming up. See, neighbor has come. Let us verify the routing table now. Show IP route. You will see detailed routes. Detailed routes. This proves that auto summarization is not enabled by default. In the presentation, we saw auto summarization is by default, which is for older version. I told you. That's the old story. Auto summarization occurs by default. No, there was no auto summarization by default. Didn't occur by default. All right. So now let us configure EIGRP in router 3 and verify router EIGRP 16 network 172.16. Now neighbor has come. Even here, the routing table will be detailed. Show IP route EIGRP. These are the routes learned from EIGRP. There is no summarization. Show IP route. There is no summarization by default. No auto summarization. Now I'm going to do auto summarization. Before I do auto summarization, I want you to see the routing table of R1 with there is no summary route anywhere. Do you see anywhere in this routing table mentioned as summary route? Is anywhere mentioned as summary, word summary? Nowhere. And do you see any interface called null zero here? Null zero? No.
No, sir.
Let us do the summarization. I repeat again, unless there is a route in the routing table, it cannot be advertised. So if you want to advertise a summary route should be present in this routing table. Only then that can be advertised. Summarization is good. See, without summarization, if you go to router 2 and check the size of the routing table, show IP route summary, EIGRP has consumed 1,892 bytes. Now I'm going to summarize and send. Let's see what. On R1, I'm going to say router EIGRP60 auto summary. If I put this command, it will summarize. But I'm not going to put. First, let me show you one more place that summarization is not in effect. See IP protocol. It says summarization is not in effect, meaning summarization is disabled, not enabled by default. The command that I used to verify this is show IP protocol. Say summarization is disabled. Okay, now I'm going to enable it. Router EIGRP60 auto summary. Now it will resync with the neighbor. It will remove the previous update and put the new update. Summarization configured. See how clearly it shows. Now let's check the routing table here. Show IP route you will find a summary route by dual algorithm. D means what? EIGRP, dual algorithm. Dual algorithm has created this, generated this, and it has put it in the routing table because it wants to advertise this to the other two. And you see the mask it has given is /8 class full boundary. Because 10 is class A, it's sealed to 8. Now I'll go to router 2 and check the routing table. Earlier when I checked, the space consumed was 1892. But now I'm expecting smaller. Look at this. It's 344. Now let's check the routing table. Show IP route, and you got a summary route. Not only here, even in R3, it is going to be summary route. Summary route. You can use the same summary route and you can ping 10.1.9.1. You can ping very well. Using the summary route, you can ping. Even from 1 to 10.1.6.1, you can ping. The summary route is sufficient for us. You already saw the advantage of summarization. The routing table was too big earlier. Now your routing table is small. See, smaller the routing table, more efficient, more faster the router will be. Because the number of lines to read before forwarding the packet is less. Not only that, the buffer utilization is less, process utilization is less. The bandwidth that consumed to send the update is also less. Before summarization, there were 10 lines of route. Now, only 1 line of route coming in. But we want a manual summarization. We want manual summarization. How can we achieve manual summarization? Meaning, I want to summarize like this. I want to summarize up to 6, 0 to 6, totally 7, 0 to 6 means how many to do? 7 network. I want to summarize up to that by putting /21 mask, and the remaining 7 to 9, I just want to get it like /24. How can you achieve that? Go to the interface F01 of R1. And say IP summary address for EIGRP 60 10.1.0 starting from 0 255.248.0. I'm saying summarize the first 7 starting from 0 7 means 255 minus 7 48, which is /21. Boom. Now if you go to, see, it's resyncing. Now if you go to router 3, only on router 3, earlier when we check it was the global summarization, but now you see sorry, this will disappear now. Oh, you know why this is there? You know why this is there? Up to 7, we said up to 6, means 7 only we have asked to summarize like that, like this, 0 to 7. The balance is auto summarized. Here we have enabled globally auto summarization. If I say no auto summary, see what happens. R1 router EIGRP 60, no auto summary. If I cancel that, then only up to 7 it will be summarized. You see, only up to 7 it is summarized, 0 to 7. The balance 2 is coming detailed. They are not summarized. Now for this, we should have route in the routing table before advertising. Let's check the route. Show IP route locally on router 1. You can see, according to what I configured on the interface, it is having a summary route. It's pointing towards null 0. But this is not advertised to router 2. Will you see this summary in router 2? No. In router 2, it will be detailed because I say no auto summary. In router 2, if you check the routing table, it's going to be detailed, all subnets. Only on router 3, you will have summarized, manual summarized. The reason is it's manual summary. Only on router 3, you have up to 7 summarized, 8 and 9 not summarized because we don't have auto summarization. When I have auto summarization on R1, along with this router EIGRP 60 auto summary, when I have this show IP route, I can see 2 summarized route with different length pointing towards null, because this one needs to be sent to router 2, this one needs to be sent to router 3. For those network which is not included in this, this will be advertised to router 3. So if I go to router 2, I will see single /8, and on R3 I'll see both. I see /8. This is for 10.1.8.1 and 10.1.9.1, and this is for 10.1.0 to 10.1.7. So what we have seen here is manual summarization and auto summarization in this lab. Now let's go back to the presentation and see whether what we are seeing there in the lab matches. Auto summarization means about rounding to the major network boundaries. You saw that. And when you configure summarization and an interface pointing towards null zero, a null zero interface, the summary route pointing towards null zero interface is generated. It is not pointing towards a particular interface. If it points, then it will cause loop. That's why it points towards the null interface. The manual summarization is done per interface basis. Now, when will the update stop going? Only if all the specific routes goes off. If I have a different metric for different network, which we are going to summarize, the lowest metric, the minimum metric of those network will be utilized. All right, this is what we used. These are the commands we used. Auto summary and IP summary address, HRP. Any question on summarization, please ask.
No, sir.
Okay. This is what we did, right? Both IP summary address and then summary order summary. Next is about load balancing. This is an important topic. So in the load balancing, by default, equal cost load balancing is supported because the variance is not by default. What is variance? Variance is an option that will help us to have unequal cost load balancing. If you do not want to have load balancing, you can set the max path 1. If you say maximum path 1, then how load balancing can be done? Not possible. I got multiple paths to reach some destination, and all the paths shows the same cost. To the same destination. From R1 to reach 1.1.1.1, if you go where E0 same cost, E1 same cost, E2 same cost, E3 same cost 5. By default, up to 4 paths out of this 5, 4 paths will be used. Load will be equally shared. Because the cost is same, because the metric is same, the load on path also will be same. If I have 500 packets to 400 packets to send, each link will have 100 packets. So totally four links, 100 packets each link per link.
Sir, can you have 3 paths
Yeah.
and then 1 path as a backup path?
No.
Can you?
No. You can have 3 paths, but if all 3 goes down,
Sir, hello.
yes, welcome.
So the equal cost load balancing is somewhat is related to ECNP also, or is that a different concept?
Both are same.
Same only.
ECMP means equal cost multi-pathing.
Correct, sir.
You see here the cost is 5555 in all link, and up to 4 paths by default will be used. If you want to increase, you can increase up to 32. A question from our Mahesh is, can I use 3 and the others have backup? If you would have asked that, then I would have said yes. But you asked, can I use 3 paths and 1 as backup? Why 1? There's 2 out of 5. If you say max path is 3 instead of 4, if you say 3, any 3 will be used. Let's say these 3 are used for load sharing, and these 2 will be waiting for any one of the link goes down. If this link goes down, then this will take the 3rd position, and if this goes down, this will take the position. It will start using this. So yes, backup will be used if you have equal cost path. Out of 5, 3 are allowed by default because you said max path 3. Not by default, it is 4 allowed, but because you said max path 3, out of 5, any 3 will be used for packet sharing, load sharing, and the other 2 will be waiting in standby. Did I answer your question, Mr. Mahesh?
Yes, sir.
Right, sir. So you can increase up to 32. Again, it is not in all operating system. Some operating system you can increase up to 16. In some you can increase up to 32. All right, next. If you do not want to do load sharing, meaning out of 5 only one link will be active at any point of time, any one link, then you set the max path to 1. That disables the load balancing. Even though you have equal cost multipathing, because you said max path 1, then ECMP cannot be used. Cannot be used. Alright, what is next? EIGRP can also support unequal cost load balancing. Unequal. If you say 4, then 4 unequal cost. If you say 15, sorry, 16, if you say 32, 32. But unequal cost load balancing is not enabled by default. By default, only ECMP. This is equal cost multipathing. By default, only ECMP. Unequal cost load balancing we have to enable. How do we enable? By using variance. But before I want to ask you a question, please answer. This is R1 and this is R2, R3, and in order to reach some network here, let's say 1.1.1.1, the metric here is 10, the metric here is 15, the metric here is 10, the metric here is 110. Okay, this is what. Now, for R1, via R2, via R3, what is the advertised distance? What is the feasible distance to reach 1.1.1.1? For R1, my question is for R1 to reach 1.1.1.1 via R2, what is the advertised distance and what is the feasible distance? What is the advertised distance via R3 and the feasible distance?
So advertised distance will be 10 from R2, and from R3 it is 15. And then for R1 the total distance would be 120. And for via R2, for R1 via R3 it will be 125.
Exactly. Now, which one is the elected successor route? It is R2, isn't it?
Via R2.
Okay. Now, will this be considered as a backup route?
Yes. Yes, sir.
Why? The
Because
feasibility
the
condition
advertised
says
distance is lesser than
the advertised distance should be lesser than the FD value. It is true. Fine. Now, listen. Only if you have a feasible successor route. This is feasible successor. Only when you have feasible successor, where will you have feasible successor? In the topology table. Only when you have feasible successor, you can tune variance in order to get unequal cost load balancing. But I'm telling you again, if you don't have feasible successor in the topology table, if you don't have feasible successor, whatever the variance you configure, it's of no use. See, this is unequal cost, 120, 125. So definitely only one route will be there in the routing table because this is not ECMP, this is not equal cost, this is unequal. So this route is there in the routing table and this route is there in the topology table. In order to make use of this route, which is available in the topology table, we configure something called variance. If you don't have this route, even if you configure variance, this path cannot be utilized. Let's say this one has got 130 as advertised. 130 is not less than 120. So this won't be there seen in the topology table in the first place. If you don't see, you cannot utilize it. If you don't see in the topology table, you cannot utilize it. Fine. Now let's go and see another example, another superb example. This is not that superb. You hear. This is what the command variance. You go under router mode and say variance and a number. Look at this superb example. Router E to reach Z, network Z, there are three paths. Via B, the advertised distance is 10, via C, advertised distance is 10, via D, advertised distance is 25. And the feasible distance are as follows, 30, 20, and 45. So which one will be the successor? E will be the successor because the lowest of the. Will there be any feasible successor? Will there be any feasible successor? Will there be any feasible successor?
Yes,
Via?
B.
Yes.
And
Via B, there is a feasible successor. Why? The advertised distance is less than the successor value 20. Whereas here, the advertised distance is not less than 20. So this won't be seen in the topology table. D is never considered to get to Z. Fine. Now, how can this be used? In routing table, you right now have only one route via C. But if you go and tell variance and then a number, this 20 will be multiplied by the number. What is the answer? 40. All the route whose FD is less than 40. All the route whose FD is less than 40 will be used. So because this 30 is also less than 40, this will be used. Mahesh, did you get it?
Yes, sir.
Now, according to the capacity only load balancing will happen. See, this is 30, this is 20. In which path more traffic will be sent via C? Compared to B, C will take more traffic because EIGRP says this is the least FD, so send more. And this 30, say for example, if I have 1000 packet, like 650 packets will be sent over C, and the balance 350 will be sent over B. Again, I'm not writing it an accurate number. I'm saying EIGRP will take care of it. There's a variation in the cost. It is because of the bandwidth and the delay. The best bandwidth and delay is found via C. So more traffic is going to be sent compared to B. C has got more bandwidth and less delay. So according to the capacity, according to the bandwidth, the load sharing will happen. But this is not ECMP. This is UECMP, unequal cost load balance. Unequal cost load balance. Variance is the key. By default, the variance is 1. What is variance? A multiplier value. This allows the router to include those routes with a metric smaller than the multiplier value. I said 20 multiplied by 2, which is 40. Any FD which is less than 40 will be used. So B will be used. This won't be even considered in the topology table, so don't care about it. Is this clear? Unequal cost load balancing. Is this clear?
Yes, sir.
Yes.
Right. The lab of this we will do in the next.